Okay, hello everyone. My name is Yusuke Yamamoto. I am an associate professor in the School of Informatics, Shizuoka University. In my part of this lecture, we will learn recommender systems, which is one of the most popular technologies in the recent ICT area. In my lectures, I will use only English to communicate with you. I am so sorry for Japanese students. But my English is not so difficult for Japanese students to understand.
So today at first I am going to introduce the recommender systems. The recommender systems are a technology to predict user preference model and determine which items should be recommended to users. So nowadays a lot of ICT vendors services use the recommender systems. The most famous recommender systems users is Amazon. Amazon recommends the items which users will like. Here is my page on Amazon.com. Recommended items are listed to me here. I think that these items reflect on my preference very well. Amazon recommends the items to users by using the similar method by recommender systems. Here is another example. Let's imagine that you are now viewing the page about felt pens. The Amazon recommends the items similar to these felt pens, like this. So even social media services use the technologies of the recommender systems. For example, Twitter. Twitter uses the recommender systems to recommend which users follows. Facebook also try to recommend articles, events, and users by using the recommender technologies. Movie and music are very hot areas to use the recommender systems. So Netflix intensively uses recommender systems technologies. Apple Music also do. I'm not sure if you know that news website also use the recommender systems to provide the news articles according to the user preferences. Of course, the advertisement companies like recommender technologies. So in this way, a lot of companies use recommender systems to personalize the information access of users. So you can see recommender systems anywhere on the web. So why do a lot of people and companies use the recommender systems? The values for users are the end user can find the interesting items and information easily by using recommender systems. Also, recommender system helps users discover the new and unexpected items. If information providers use the recommender systems, the system contributes to the increased trust and customer loyalty. The recommender system can increase sales, click rates, and conversion rates, and so on. So recommender systems are very important for both end users and companies. Now, how do recommender systems work? Here is a brief description about the paradigms of the recommender systems. A typical recommender system, at first, to predict the user preference model, and then the system make and show a list of items to recommend using this preference model like this. So the point is how to model the user preference and how to compute the relationship between the items, and user preference. To compute user preferences, the system uses three kinds of information like this: user profile, community data, and item features. Here, the community data means the user behavior data of other users, a lot of users. Okay? So, recommender system is one of the hot topics in the computer science. So, a lot of researchers have proposed the method for the recommender system. There are three main approaches for the recommender system. The first one is the collaborative filtering. This approach focuses on the user behavior logs to decide which item should be recommended. The second approach is content-based filtering. This approach focuses on the item features and their metadata to recommend the items. Okay? The third one is the knowledge-based filtering. This focuses on the preference information which users explicitly and manually specified in their setting. Okay? These are three main approaches for the recommender systems. Here I'm talking about the mathematics a little bit. The core of the recommender system is a mathematical computations. So here is a problem definition of the recommender systems. Typical recommender systems accept two kinds of information as input data. The one is the user behavior data logs. Okay, for example, what did user purchase? The other input is the item set, item informations. Okay, using these input data, recommender systems output a ranked list of items to recommend. The system obtained this ranked list by calculating the relevance between the user profile P and items. Here, the point is how to model the user profile, and the another point is how to compute the relevance between the user profile and item. So in my part, we will learn the methods to model the user profile and to compute the relevance between the user profile and the items. Okay? So from now, we will learn these four topics. Unfortunately, if we don't have enough time, it is possible that we will skip one of these topics. So in my part, I will provide the lectures to you, and also we will do a programming assignment, programming work, so that you can see how each method works. Here is a reference. If you get more interested in the recommender systems, I recommend you these books. Okay? Okay, let's dive into the detail of the recommender systems. Now we will learn the collaborative filtering. As I already said, collaborative filtering is one of the main approaches for recommender systems. The collaborative filtering focuses on the user's rating data to model the user preferences and to recommend the items. To use collaborative filtering algorithms, we set basic assumptions. Firstly, users give ratings to item appropriately. The secondary, rating patterns helps us to predict the ratings for the unrated items. Practically, collaborative filtering has several good points. large commercial e-commerce sites use this collaborative filtering. For example, Amazon.com. The advantage of collaborative filtering is easy to understand. And furthermore, this method, collaborative filtering, is applicable in many domains if you can obtain only rating data for items. To think about the algorithm of collaborative filtering, let's see one example. Here are 5 items. Alice already purchased these 4 items, and she rated each item like this. She hasn't purchased the item 5. Here, the question is how much does Alice like this item 5? Okay? If Alice is likely to rate this item 5, highly, we should recommend the item 5 to Alice. Let's observe other users' rating informations. Here is the rating information of 5 users, including Alice. How can we predict Alice's ratings to item 5 by using these informations? When we see this table, we find that the Alice's ratings trend is similar to user 2, to the user 2's ratings trend, because Alice ratings is 5344 and user 2 ratings is 4343. On the other hand, we find that the user's 4 ratings trend is not similar to Alice's rating trend, because Alice's rating trend seems to be reverse against the user's ratings trend. From this observation, we intuitively think that Alice will give high scores to item 5. Now we have obtained the intuitive idea to predict the rating scores for unpurchased items. The intuitive idea is we focus on the rating scores of similar users. The point here are how to compute the user similarity. How do we combine the rating scores of similar users to predict the Alice's rating scores to unpurchased items? How many similar users should we consider? These are the point. In order to compute the similarity between the users, we can use the several metrics. One is Pearson correlation coefficient, which I think that you already know. Here we denote UA and UB as a user A and user B. Also, I means the item set. The R bar means the average rating. RUAI means the user's ratings, user A ratings, user A's rating to item I. This formula seems complicated to some students, but this formula is just a correlation coefficient. Okay? By using this Pearson correlation coefficient, we can calculate the similarity between the users and users. For example, the similarity between the Alice and user 1 is 0.85. This value is very high. The value indicates a user 1 is very similar to Alice. On the other hand, the similarity between the Alice and user 4 is minus 0.79. This value is very low. this information indicates that the user 4 is not similar to Alice. So how about the similarity between the user 2 and Alice? Let's calculate. I'll wait for a while. Okay, the answer is 0.71. Through this example, we found that the Pearson correlation works well to compute the user similarity. Here, this graph indicates the rating scores of each user. The graph has the same information as this table. As you can see, user 1, green, right, on green line, gave the smaller score than Alice. But the user 1's rating trend is very similar to the Alice rating trend. The Pearson correlation coefficient is a measure of the linear correlation between the variable x and y. The correlation coefficient can catch the trend similarity by ignoring the magnitude of the values. Okay? This is the advantage of the Pearson correlations. After computing the user similarity, the collaborative filtering method predicts the rating scores for unpurchased items by using the user similarity. This is a typical prediction function. Okay, the formula seems complicated, but the idea behind this formula is very simple. We check how similar users rated item I to predict the target user's scores for item I. Okay? So let's use this formula. Let's see an example. Here we want to predict what score Alice will give to item 5. Let's assume that we found user 1 and user 2 are very similar to Alice. Okay? Here we assume that these users are similar users to Alice. The similarity score between the Alice and user 1 is 0.85, and the similarity between the Alice and user 2 is 0.71. 0.71. The average rating score of Alice is 4, and the average rating score of user 1 is 2.4. Okay? And the average rating score of user 2 is 3.8. Okay? And furthermore, user 1 gave the 3 points to item 5, and user 2 gave the 5 score to item 5. So let's input this information into this formula. Okay? As a result, we have predicted that Alice would give 4.87 scores to item 5 through this formula. Okay? This is a collaborative filtering. So in this example, we assume that user 1 and user 2 are similar users to Alice. But how should we choose the similar users? How should we set a threshold to find similar users? There are two ways to decide the similar users. Technically, we call the similar users as the nearest neighbors. The one way is to set a threshold for user similarity. if a user has a higher similarity than a threshold, so then we consider that the user can be similar users. When using this approach, if we set too high threshold, it is possible that we cannot find similar users in worst cases. Another approach is to focus on the top k similar users. If a user ranks at the top k similarity, we consider that the users can be similar user to a target user. In practical, threshold k is often set to between the 50 and the 200. When using these approaches, in worst cases, I recommend the systems use the rating score of users with low similarity. Okay, this is about how to decide the similar users. Okay, that's all about the collaborative filtering. Here is a summary slide about today's talk. Today we've learned about the user-based filtering, user-based collaborative filtering. Next time, we will learn the item-based collaborative filtering. Okay? That's all about today's lectures. Okay, it's time for programming work. So in order to start the programming work, at first, please click this URL and move to this website. So when clicking the previous URL, you will see these web pages like this. This is a website for my course to learn the recommended systems algorithms. Okay, every week I will upload the programming materials on this website. Please remember that. Okay. In this programming work, we will use the Python, which is one of the most famous programming language, and also we will use the Google Colaboratory. Google Colaboratory is a Python environment on website. So you don't need to prepare the Python environment on your PC manually. Okay. Okay. So let's start doing the programming for today's content. At first, please click the URL in the content list. So then you will move to the Google Colaboratory web pages like this. Okay. So in order to use the Google Colaboratory, we need to log in the Google. Okay. For that, please click the this blue sign in button on the upper right corner. Then input the information for login Google. Sorry. If you succeed in the login the Google, you will revisit this web pages. Okay. So, in order to learn the several collaborative filtering methods, I prepared several programming codes like this. In this course, all you have to do is just read this document and run the programming code, which I already prepared. So that means that you don't need to write the code manually. So I think that some of the students are not familiar with the Python code. Don't worry about that. You don't need to write the code. Just run these code which I prepared. Okay? So let's run the code. On the Google Collaboratory, in order to run the several codes, click this triangular button on each code. Okay? So let's click the first code. So if you maybe you see this warning messages. This is for the warning. This is a warning for the security, but please ignore. Please click the Run Anyway button. So then you finish the running code. Okay? Some of you think that nothing happened, but the first code already ran. Okay, let's run the second code. Please click the triangular button on the second code. So then you will see the results of this code. Okay? So from now, you please read this document and run the several codes to run the collaborative filterings, which I talked today. Okay? Okay. Please notice that at the end of this document, you can see the assignment section. I prepared some assignments for this programming work. This is for the practice. You don't need to submit this assignment. So just use these materials for your practice. Okay? Okay, that's all about today's talk, today's lectures. So please enjoy these materials. Okay, see you later. See you next time. Bye bye.